Going to announce that right now. So welcome to class 2 of Data Analytics 3, which is our Python class. And we just granted access to everyone to the resources, and the files that we're going to be using tonight are the Iris dataset download. It's a zip file. And then there's an image, Iris types. I knew I would say that. I'm predictable. What can I say? So it's a JPEG file that basically is a picture of irises. And one of the goals that I have is to show you how to bring an image into your Python notebook so that you can actually see what it is you're talking about as you're analyzing it. How cool is that? So last week, I'm just going to recap. Last week, we talked about binary classification. And I do see that some of you posted your homework, and most of you have a really good understanding as to what binary classification is. What I want to do is remind you that binary classification involves one column or one feature that is a target variable. And so your target variable has to be binary, either yes, no, on, off, subscribed or not subscribed, spam, not spam, what have you. So it's either going to be a 1 or a 0 or true, false in state, right? So if your homework, when you were doing it, if there was any confusion or what have you, you want to just review it again and say, okay, let me see, is my target variable a binary variable, meaning it can only be 1 or 0. So that means that a numeric value that it's not as 1 or 0 is not a valid target. Okay. The other thing that's not valid is something that is not measurable as either or, one possible choice. Okay. Now, tonight, we're going to be doing very similar process and procedure, but multi-class classification. So multi-class classification is awesome because it's often the case that we want to determine between two or more possibilities. Technically, it should be 3, my bad, because binary, 3 or more possibilities, which of the possibilities it is. So for example, and I'm going to share the lecture notes with you in a minute, but a really quick one, I want to determine if the animal that is described in my data is a fish, a bird, or a dog, right? And it can only be one of those flavors. It can't be all 3. Good Lord, can you imagine? And it can't be 2, right? So it has to be just one type of animal. So that is a multi-class type of scenario, okay? Now, another possibility, and I'm just talking about it before I bring up the notes, is a multi-label classification. So think of books. Books can be nonfiction and a particular type of genre. That means 2 things are used to describe them. So that's multi-label classifications. So you might be able to come up with a question involving predicting all the books that are nonfiction and, let's say, in the genre of mystery. Okay. And based on their characteristics, determine whether or not this particular book is that type of book. Okay. So that's, just in a nutshell. And again, one of the things that we ended with last week, and I want to start with this week, is um, these types of terms and such can be confusing, right? But I don't want you to get discouraged. I want you to just think about how much you've learned since you started this whole class, right? So it's really about your growth relative to where you were. If you think I'm going to forget things or I don't get it, focus on one thing that you remember, right? Focus on something that resonates with you. And I think that, you all are doing a great job. So you should give yourself a pat on the back. Okay. All right. That being said, and time being of the essence, I am going to share my screen with you so that I can get into the PowerPoint, because that's where all the factoids are, right? That's where all the goodies are. And again, the PowerPoint is put up on OpenHub as a PDF file, which I hope works for you. Most folks like that. All right. So multi-class classification. How cool is that, right? How cool is that? So multi-class classification, and forgive me while I'm just going to toggle off the subtitles. Multi-classification is also a supervised machine learning algorithm. that is used to classify new observations into one of multiple classes. So it's very similar to binary classification, right? It's very similar because it involves classification of some type. In this example, though, we have more than two flavors. We don't have a binary scenario, we have a multi-class. So it is supervised because we provide the data to the model so the model can learn, right? So we say, hey, model, here's some data, here's some examples, and we want you to learn. So we're supervising your learning because we're giving you the answers basically, right? And given the answers, can the model then guess new data when we send it after we train it? So a multi-class is a categorical state assigned to each observation, but it's based on three or more possibilities, right? It's based on, for example, what color is the t-shirt? It's either red, green, or blue, or it's it's either a dog, cat, or a fish, or it's maybe just it's a swap between a dog and a cat. So let's say there are several different ways of classifying a particular observation. That is going to be a multi-label because you don't want to have more than one in that target field. All right. So it is predictive modeling technique, just like last week. And again, one of multiple possible classes is used to classify it. All right. So let's look at some additional information on this. So we still have explanatory and target variables. So the explanatory variables are your predictors. They're the fields, if you will, or variables that are used to learn what a dog looks like, or learn what a iris looks like, or learn, what are the characteristics or attributes, right? And then a single target or response variable, also known as the dependent variable. So um, the explanatory or predictor variables are independent, the target is dependent. We're measuring or predicting the dependent variable. Is it a fish or a dog, right? Is it an iris or a rose? So that's what we're basically trying to predict. So explanatory variables can be numeric or categorical. If they are categorical, we have to massage the data because they're not numbers. And a model, just so you know, and I think I've mentioned this several times, a machine learning model cannot ingest categorical variables. It has to work with numeric data. So if you plan on using categorical, you have to convert them or one-hot encode them. And we're not going to do one-hot encoding tonight. I'm going to save that for another day because we're learning about the different possibilities. And then we're going to, and we've been working with primarily numeric values. So we're not going to get hung up on that. So the explanatory variables are the ones that you use to predict the outcome. All right. And again, feature importance, just like last week, is going to be very relevant in that we engage in feature importance to see which features are highly likely to predict the outcome. For example, is it the fin size on the fish that determines the type of fish it is, or so on and so forth. With a bird, maybe it's the wingspan that determines whether it's a predator or not. So we have to determine which features are highly important in the analysis. These steps are the same as last week. How cool is that? So the process of classification is identical to what we did last week. There are some small tweaks to step 4, in that you tell the regression model when you create it that this is a multi-class scenario. Okay. And I'll show you how that's done. But basically, the steps are the same. So that should be good for everyone, right? Easy peasy. So now, this is going to be confusing because you're going to see binary classifiers on the screen and say, wait a minute, this is multi-classification. I don't get it. I'm going to explain. So multi-class strategies use combinations of things. So it actually takes pairs of possibilities and it compares them using either a 1 versus 1 or OVO or 1 versus rest, OVR. So, and when I show you in our example tonight, it'll make perfect sense. All right. So what happens is the model, as it's doing its work, it creates different combinations, says, well, let's combine these and look at them, and then let's combine these and look at them, but it does it in pairs. It makes it easier for it to slice and dice. All right. So look at an example. A target with 4 classes. It's either a dog, a cat, a bird, and a fish would have 6 possible combinations or pairs, right? Dog cat is a combination. Dog bird is a combination. Dog fish is a combination. Then cat bird is a combination. Bird fish is you see where it goes? So there's 6 possibilities. And what it does is to make sure that performance isn't a hit, it does logical combinations. Now, I will tell you that OVO, because it's doing 1 versus 1, takes a lot of horsepower to run, meaning the computer, the server, because you could have lots of different combinations, right? And for those math people out there that love math, permutations, right? All different possible combinations. You see that the more possibilities, the more likely it's going to take more time. So this can have an impact on the training process. So it's just something to think about. So OVR in general is preferred. But when you use OVR, you have to watch for imbalance classification. So for example, in combining, let's say dog and cat, maybe I only have 5 records that are possible dogs, and maybe I only have 2 records that are possible cat. Well, now I have an imbalance in classification, right? So what we are going to do tonight is we're going to set our logistic regression model to auto. So it decides what it needs to do, and we don't have to worry about it, okay? So now these steps are identical, but you'll notice the syntax, the code is different. So last time the code for line 2 looked different, and basically the reason it looks different is because we have different data set and different number of columns, right? Therefore, where we locate the values for X is going to be different than Y. So this particular screenshot represents last week's data set. When we do our example tonight, you'll see that I switched the values, and that's because we have different values, right? Or actually when you do your homework, my bad, you'll see that you need to tweak those values. So instead of a 4, you're going to have to look at, well, what do we have in our new data set? Okay. So species is going to be the target value, all right, or variable. And we're trying to predict our iris species. That's why it says species. And we have 3 different possibilities of iris. So that's why it says species. Now, when we split our data set into training and testing, we're going to do it very much like we did last week. We're going to leave the test size at 25%. And that means that how much is being used for training? Who knows the answer? Someone knows the 75. Did someone said 75, right? Awesome. Awesome.
Yes.
All right. Excellent. So 75% will be used to train the model, 25 will be used to test. So basically our novel data set is the test set. So 25% of the possible data that we have will be utilized for testing. Once we've trained the model with the training chunk of the data, the 75%, we hope the model has learned. And then we're going to feed it the test set to see if, in fact, it actually has learned and our model is performing with a level of accuracy that is acceptable. Okay. Random state is 0. Why? Does anyone remember why we leave random state to 0? Anyone? And it's okay if you don't remember. It's all right. So random state is usually not left to 0. Let me explain why. If you leave it to 0, it doesn't randomize each time you run your code. So it remembers the old version and it keeps going after the old version. And that's not good because you're not going to effectively train. I have this set to 0 is because I want everyone to see the same results in class, or else someone's going to say, well, mine looks different than yours, Dr. M. Why is that? Because we didn't set random state to 0. So that's why we have it set to 0. So if you are practicing, which I know you folks will be doing a lot of practicing, it's okay to leave random state to 0 because you're trying to see if you are able to get the answer that you're looking for and you're learning this stuff, right? So leave it to 0 for the purposes of learning. But in the real world, every time we actually do our split of our trained test, our data sets, we want it to shuffle it and get new values, right? We don't want it to cheat and use the old values because it practices and it gets really good, right? And so it may fake it that it's doing really well, and we don't want it to fake. But in this class, we can. All right. All right. So normalization happens after you split the data. Why? Because we need to normalize so all numbers are on the same scale. But we want to make sure that the model does not engage in attribution bias. We don't want it favoring numbers that are greater than others. And if we normalize before splitting the data, we run the risk of leakage, meaning that it combines the data in a way that doesn't allow it to learn. It actually combines the test and the trained data sets together, and that's not a good thing. We want to keep them severed and separate. What it was trained with, it never saw before when it was tested. So you never want to give it a hint. So if you feed it a little bit of training data when you're testing, you're basically skewing the model to guess based on what it saw prior. You want it to act like it never saw the data before. And so there's no chance of, data leakage, and there's no chance of the model basically faking a good performance, right? It's actually performing really well with new data. That's how you judge a model, by the way. When you give it new data that it's never seen before, if it's able to predict the values with a high level of precision, then you know your model is good and you can put it into production and let everyone else send data to it. Okay. So in the process of fitting the model to the training data, you're actually getting the model to learn. So in this case, we're using logistic regression. We're leaving the random state to 0. We are using solver and a particular type of solver. I'm not going to get into the specifics, but it's a mathematical model that it applies to your model, your logistic regression model. And then multi-class is needed because this is multi-classification. Now, we didn't use multi-class last week because we were doing something different. We're setting it to auto instead of OVR, right? And so that's basically, and I'm going to answer Renita's question. Yes, yes. In a second, Renita, thank you for your question. We're going to set it to auto so that the model decides what is best for the data. And then, of course, fit the data to the model. So to shuffle the data is basically to take your data observations and shuffle them around so that each row keeps its values for that given row, but we kind of sort it and shuffle it so that, again, the model doesn't memorize the position of where those values were. Remember, we're dealing with machines that have great way of looking at location. Remember some of the code we gave it is what cell is this? Well, the model's going to remember. So we want to shuffle the data around so that the model is clueless, okay? And so next time we give the model the test data, it's basically going off the test and not its memory. So did that help, Renita? I hope. Now, shuffling does take some horsepower. Shuffling basically is a mathematical flip-flop of your data, to use layman's terms. We will be doing some shuffling in future classes, and I'll show you how it's done. And we will be thankful that we don't have to do it. We just press a button, okay? Because nobody wants to shuffle it. All right. It's like 52 card pickup, but it's more than 52 cards and they're everywhere. And nobody wants to do that, right? So again, it's just a way of, think of it this way. You don't want to give an advantage to the machine that it doesn't, that would possibly cause it to bias towards a particular result. It's like, oh, this result is common, therefore we want to always fake out that model and say, you don't know what this is, and kind of, shuffle it and say, now tell me what's going on with the data, right? So again, it's just a mathematical principle. Now, predictions using test data is very, very important. So The goal is that the data you are sending for testing purposes is data the model has not seen before. That's why we do the train test split. We have a train set for training and getting the model used to what this data is. And then we have a test set, which is novel data. It's sort of that cookie dough that's on the side that I talked about last week. It's never tasted said cookie dough. Then we give it the cookie dough and we ask it to do what it needs to do. All right. So the goal is to create an array of predictions, all right, based on the test data once we've trained that model. And that's step 5. Now, this is kind of hard to see because it's kind of big. So I'm going to show you a little bit different way of creating the confusion matrix. Remember, the confusion matrix is basically based on the test data set and the prediction, right? So predicted versus actual. How many of the guesses that the model made with the test data did it get right? That then is used to calculate your model accuracy. So that is something that once you train your model and you know it's working well, you then feed the model the new data that it hasn't seen and say, okay, how confused is the model? That's what a confusion matrix is. Does it guess more accurately than not? You know, where is it at? So this is basically going to give us a different printout for tonight's purposes, very similar to last week, but it's using basically a for loop, and it's a nested for loop with an if-then statement. So this gets you practicing some of your Python skills as well, all right? And then, of course, it's going to print out the result, how many correct predictions, how many false predictions, and what the overall accuracy is. Okay. All right. And of course, the accuracy score for the binary classifier, again, it is a binary classifier because of how it makes those pairs. But this is a multi-classification, all right, is this particular formula. So true positive plus true negative over true positive plus false positive plus true negative plus false negative. That gives you your accuracy score. Now, we're not going to generate one of these tonight. That's all pretty and fancy. We're just going to generate the accuracy. And then we're going to talk about additional metrics, which we talked about last week. This again is that confusion matrix and what it looks like. We're going to do it in a very simple way, just using text tonight. All right, data leakage I talked about a minute ago. This is the same slide as last week. So again, if you're not sure, you know, I'd highly recommend you watch the video from last week. But again, this gives you some ideas to why we want to avoid data leakage, okay? Now, the metrics. We last week talked about accuracy, precision, and recall. Accuracy was the ratio of number of corrective predictions to the total made. So we made X amount of predictions. How many did we get right? That's basically a ratio. So it will turn into a percent. And that percentage, right, we want to keep it, we would like to be 80% or higher, ideally. Now, if you're in the 70s, not so bad. Typically, that means that maybe you had a small data set. Maybe you need to tweak some of the hyperparameters, which is outside the scope of tonight. But your goal is to try and keep it on the high end. Now, the precision metric is the number of actual positive cases correctly returned by the model. So it's focusing on the actual number rather than the ratio. But in essence, the ratio of number of correct predictions, you know, accuracy is very similar to precision. It's just the actual number. And then recall is the proportion of actual. Okay, so you kind of see how they work together. Now, there's 2 additional metrics tonight, the F1 score and support. F1 is a score that is used to determine the model's accuracy. It's an average of the precision and recall together. It's an averaging metric, okay? And then support is the actual number of occurrences of the class in the data set. So what this means is, and I'll give you a scenario. Let's say we're trying to determine if mail is spam, and we know that some are spam and some are not spam, or at least they're supposed to be, right? And we basically create our model, we give it data, and then we find out that we had very little support for spam. Let's say you had 500 records and only 100 of them were spam. Well, that's a low support relative to the 400 that were actually not spam. So how can we train the model if we have an imbalance like that, right? Here we have 400 not spam emails, which are good, which we want in our inbox. We only have 100. So that would be low support. So you want your support to show that you had enough occurrences in your data set to basically train your model, right? It supports the goal. It supports the model's ability to learn. So that's what you want to think about when it comes to support. How much support do you have? How many actual occurrences of the class that are even in the data set? Is it possible that we had such an imbalance, that we need to get some more data? That's a possibility. All right, and then of course we can display our performance results. This is how we did it last week. We will be doing it a little bit differently this week, but the goal, once you know the result, is to display it in a graphical way and also in a text-based way. It's always a good idea to do when you're done. So in summary, very similar to last week, multi-classification is supervised learning algorithm. It's a machine learning algorithm. A multi-class is a state described by the target variable using one label. So it's either a fish, dog, or bird, right? It's either 1, 2, or 3. It can't be all. Multi-label is a state described by the target variable using more than one label, nonfiction and mystery, right? So any given book can be described whether it's nonfiction or fiction, and perhaps the genre that it's in, like, mystery, classical, whatever, right? And so that determines whether or not you need a multi-classification algorithm or a multi-label. Multi-classification is predictive modeling. So that's what we've been focusing on last week and this week, is predictive modeling, and it involves the assignment of a class label, one of multiple possible classes, to the input data. So it's either a fish, bird, or dog, right? It can't be all three. And there's 6 basic steps and 2 basic approaches or strategies, either OVO or OVR, and scikit-learn lets us default to auto, so it can determine which is best. And that's what we'll be using tonight, is auto. Okay, so any questions about this? I know it's a lot of information, but I'm hopeful that by going from binary to multi-class, you start to see the similarities. Okay, any questions, anyone?
I had a question.
Yes.
Me
With
too.
support, the actual number of occurrences.
Yep.
They're like what it's called, like, status quo, like 50-50, or is it just dependent on what you're researching?
That's a great, great question. Oh my gosh. Okay. So you do want a balanced presentation, a balanced data set. Ideally, if you have 50-50, that's great. Okay. Not always going to happen, but really what you want, and I'm so glad you asked this, because you want support where you've got spam, not spam, or let's say fish, dog, and cat. Forget spam, not spam. Fish, dog, and cat, and you've got an equal amount of each, right? It would be ideal. Now, if you're slightly off, which tonight you'll find the data set we're using is slightly off, that's okay. But if it's drastically off, then you want to ask yourself, is the data set capable of training the model? So let's say we were slight on the fish data, right? We didn't have enough fish. It's highly likely that the model's not going to do a very good job. And if you give it a new data set that is fish related, right? Because it didn't have enough to work with. You'll know that based on model performance, and it will tell you numerically if it's struggling. Okay. So did that answer your question?
Thank you.
You're welcome. Okay, we have another question. Someone had another question? Yes, yes, yes. I heard someone. I'm not sure who. Any other questions? I thought I heard someone, but maybe I'm wrong.
It was Mackie.
Oh, hi, Mackie. Okay, I heard you. Yes, what's your question?
Towards the last part of the slide, there was something that SQ.
Which slide after this one?
The last page of the slide, the very last. Stop there. When you're talking about there are 6 basic steps, and then there's SQ learn defaults.
Yes, SK learn default.
Yeah.
Okay, sklearn is a library that we used last week. We're going to use it again this week. So scikit-learn, or sklearn, which is what you call it as a variable. Scikit-learn is used very much like Pandas and NumPy, but scikit-learn allows us to do these types of logistic regression models and such. So it defaults to auto. Instead of you selecting or specifying OVO or OVR, it actually, for multi-class purposes, it will default to auto unless you specify otherwise. All right. But you have to tell it that you're working with a multi-class, and I'm going to show you how to do that when you create your logistic regression model.
Thank you.
You're welcome. You're welcome. All right. So if there aren't any other questions, I'm going to stop sharing that screen. And I want to remind everyone that you want to download the IRIS data set. It's on OpenHub. And you want to download the image. It's an Irish types, I believe it's called Irish types. My goodness. Yeah, iris_types JPEG. Oh, yeah. I promised myself I wouldn't say that. And I'm saying Irish more than what can I say? All right. So you want to get that downloaded. And again, make sure you expand or extract the zip file, and that will be your data set. So I'm going to go ahead and share my screen. What can I say? Sometimes, even teachers will say, I'm not going to say that. I'm not going to say, I said it. I said it. So anywho.
Sorry, I went
That's
to
okay.
this is Mackie. I went to the OpenHub, and the data that we're downloading is
the IRIS data set.
Yeah, no, I hold on one second. I gotta go back. I can't. Hold on one second. Let me let me just go back to OpenHub. So I'm on OpenHub. It said lecture, which is what we just covered, and the iris type is the image.
The iris types is the image. Yeah.
Right. Where is the file?
What file?
You said we had to download the iris, just the iris type image. That's all we're downloading?
No, you have to download the data set.
Yeah, where is that?
It should be right above. It says iris data set. Iris I mean, it's a zip file. Does anyone else not see it?
I don't see it.
For class 2. It's on class 2.
Oh yeah, okay. When you click on the bottom, bottom right, it says data. You get another file that says iris data set, data analytics 3, class 2 lecture, etc., etc.
Yeah, I'm not sure why you had to click an extra time. Once you're on the page, everything is there.
No, the first page is like just listing everything, and then you got to click.
You have to click the link to get to your class. Yeah. So what you have is a hyperlink to get to the class page. And each week, as we set up the class page and get it ready for you, the hyperlink will work. Right now, we're only on class 2, so that one is the one that's working. So remember, the course has many classes. It's a one-to-many relationship. Our course is our Python course. The many side is the classes, and there's 5 classes in it. Maybe that helps if you're into database theory. I don't know. Now, it's a small data set, which is good, because it'll give us a chance to really understand how multi-classification works. But you do have to unzip, because if not, it's not going to work. Okay. Once you have that downloaded and you know where it is, you want to log into Google, log into Colab, create a new Colab notebook like I have on the screen here. And can everyone see the screen okay? And once everyone's ready, then we'll move forward. We'll just wait till everyone gets situated. I know some people got access a little bit late, so we'll just give you a chance to get situated. And if anyone does not have access, just raise your hand or let us know. I believe everyone should have access by now, but just let us know.
I have a trouble finding the file, so I am at the Tech Academy Data Analytics Bootcamp
Okay.
under Data Analytics 2 Exploratory Data
Yeah,
Analysis.
no, we're in 3. You want to go to the next one. So we're not in
3.
2, we're in 3. We're in Python and then class 2. Yeah.
Data Analytic 2, class 5.
No.
Class
Data Analytics 3, class 2. So you found it?
Yep.
Okay,
Yep.
good. Yeah.
Okay.
Yep, no
Thank
worries.
you.
No, you're welcome. No worries. Excellent. And there's a link, thank you, Bryant, in the chat on Zoom. So if that helps anybody get to where they need to be. All right.
The file is downloaded as a CVS.
It's a CSV.
CSV, I'm sorry. CSV.
Yes,
So
it's
so I don't know how to unzip it then. It's already
no. It is a zip file and you have to extract it. It's a CSV, but it's within a zip file because we do not upload CSV files directly to OpenHub. So you downloaded a zip file and that zip package contains a CSV. So you just want to make sure you extract it. Did you get it, Mackie?
No. No.
Okay, so when you downloaded it, did you extract?
It's not asking me. There it is. Okay. It doesn't, it's a zip, right?
It's a zip file, yes. So you have to double click on it.
Yeah,
and then you'll get a prompt to extract.
That's the thing I'm not getting this time. I don't know why. But is it just like a Excel sheet with a bunch of numbers and like different labels?
I wouldn't classify it as that. What's that?
Not to be offensive.
No, but I wouldn't, I can't classify it. Is it just at, yeah, I don't know what you mean.
It looks like a sheet, like Excel sheet with like.
Well, a CSV file is a comma separated file, and it can be tab separated or comma separated. And so it is a CSV file, but it is a text-based CSV. It will open up in Excel. It will also open up in a like Notepad, but you don't want to manipulate it or wrangle with it. You want to just extract it so that it's raw and nothing from a binary point of view gets attached to it. So I would ask that you just extract it. Just extract it so you have access to the file, but not to open the file. If that makes sense. So was anyone not able to extract the CSV file from the zip?
I'm in trouble, but you know, what could I say?
Well, do you want to share your screen or you're not able to share?
Yeah, I think I'm able to share. Hold on. Let me go to Zoom. Share screen. Okay. Are you able to see my screen?
We see Data Analytics 3 Class 2. We see OpenHub.
Okay, so you see that this is the file right here?
Yep.
Like click on it, it goes and
all right, you've done it a couple times. You see it up there, so click.
Yeah.
Go to the location where you downloaded it.
Yeah. Sorry.
So do the first one.
Away. Hold on.
You see where it says iris.zip? Can you click on that over there?
Yeah.
Down, right there. Click on that.
See, it doesn't even show me the.
Okay, the file has been extracted several times. It's in your downloads folder on the left there. You see iris.csv.
Yeah, so that's why
do not use _2 or 3 because it will not read. into our, because
Oh,
our
so this one is good?
that's
right
the good
here?
one. You got it. It went into your downloads folder. So it looks like your machine is set up to automatically download to the downloads folder, which most times that's the case.
Which is extracted already, right?
Yep, yep.
That's what I was asking because I was like, I don't
Uh-huh.
see the button.
Yep,
But there's
yep.
two occasions when I needed to click the button. So now it's like, so this is what I meant when I said, is it just an Excel sheet? with
Right, right.
options?
But you do want to close it because you actually have opened it up in Excel and we don't want it
so
opened.
we don't want to open, we just want it in the download file for later to extract
Well,
it.
in a few minutes, we're actually going to be ingesting it in. Yes.
Perfect. And let me
Okay.
sharing my screen.
All righty. Thank you. Thank
Alrighty.
you. All right.
Thank you.
Yep,
Wait,
no worries, no worries. Yeah, for the most part, you know, people when they download, you know, unless you change your preferences, it'll go to downloads, which is kind of nice because this way you don't get lost. You know what I mean? It just like always goes to where you think it's going, kind of thing. All right, so what you want to do is create a new Google Colab notebook. I named mine multi-classification. Hopefully, can you all see this? Hopefully, yeah. So just like last time, we are going to create a new section. And for those that might not remember, at the top here is a little button with 3 dots. It says Table of Contents. We're going to click on that and click on the section button. And it's very easy to create a new section. You just double click on the words New Section, highlight the words New Section, and we're going to type problem statement. Why? Because the problem statement is important, right? And then to get out of this window, just double click on the right-hand side, which is your preview pane, and that will update your section name. Okay. Everyone good? Now, underneath this, we're going to create a text cell, and we've done this a couple times. So you want to just mouse over and click text, and I'm going to paste in what we need so that you can see it. So I'm not gabbing when you're trying to type it. Our goal tonight, our problem, is we want to create a multi-class logistic regression model to predict the type of iris flower based on its characteristics or features. Our data comes from that research lab that we used last week from University of California, Irvine. And the iris data set has only 150 observations or records with only 4 features, right? It's always good to put some information that was redundant, but hey, at the top of your problem statement, just so that you have some context of what it is you're doing and why. Okay. Now, you'll notice here that my 4 features and my 3 classes are not listed nicely. It's messy, right? Look at this. Oh, yuck. So to fix that,
are we supposed to type, I'm sorry, to type all of this that you just put in there?
well, I would say it would be a good idea. Yeah. Unless you choose not to. I mean, I don't want to force you, but yeah, um, it's a good idea because you want to have your problem statement. You're learning the importance of a problem statement. But you know, if you feel you don't want to type it, that's fine too. I want to show you how to fix this. Notice how this kind of came in yucky. It's not ordered nicely. All you have to do is double click to get back in that cell and watch this. This should be a list. So I'm going to put thank you, asterisk and a space. My goodness, it's one of those days. An asterisk and a space. And see how it turns blue? Now I'm getting my bullets. This is a markup language, right? So I'm going to show you that it's not a bad thing if your text doesn't come in the way you want. You can always fix it. Okay. This is just the easiest way to do it. And notice your preview updates on the right when you make these changes, so you know if you did the right command. So now everything looks good. I am going to put an additional space in between those two and actually get rid of that because I don't like it. There we go. Ah, that looks better. Now it's more readable. Remember, you're communicating to yourself and to others. From a data science perspective, this is very meaningful. First thing I see is 150 instances, and I'm like, okay, we'll see about this. And 3 classes? Oh my goodness. What are the odds there's 50 of each class? What do you think? Do you feel lucky? I'll give you a hint. There isn't an even number of representation for the classes. But that's okay. How's everybody doing? Okay? Getting there? So the next thing we do, and I'm just going to move forward a little bit, is we bring in a new section, and this is for importing our libraries, because that's what we need. We need libraries to do our work, right? So again, I'm just double clicking on the preview to update it. Okay. Now, if you're still typing the problem statement stuff above, you can do that after class if you want, just to stay caught up. Of course, you'd have to watch the video to, do that. But, because we have, quite a bit to do. And this way, if you feel nervous that you're not going to stay caught up, you can do that. All right. Now, what are the odds that we have a lot of libraries? What do you think? Did we have a lot last week? Memory serves us well.
Well, you had used like 3 and then the other ones just automatically came in, right?
Well, we copied and pasted them in.
Okay.
Yeah, so the others, I wish libraries would automatically come in. That would be nice. It's like, I want this library. Please show up. Or show up now. I didn't bring it in and I don't want to reload my data. That's always, you're always praying to the data science gods, right? So what I'm going to do is I am going to paste it in Slack under data analytics homework, the libraries that we are using. Okay. This way, these you don't have to type. Now, I'm going to explain what each one does in a minute. Okay. Well, I want you to get it copied in there and to at least execute it and get your libraries loaded.
Is it possible to put them in a chat or in a Zoom?
Yes, absolutely. Absolutely. Now, I hope they come in okay. Sometimes it comes in wonky, but I'm gonna give it a shot. You want to make sure it looks like what's on my screen. If it comes in a little wonky, when you copy and paste it over, make sure everything's on one line, kind of, you know what I mean? Because sometimes a Zoom chat goes crazy.
Well, at least you can have this. The bonus is just the past of this, so should take it. Oh, dear God.
All right. Was everyone able to copy and paste it in and run it successfully? Hopefully. Maybe.
Nope.
Okay.
But I could always catch up. I don't want to hold anybody back. I'm still typing. I'm down to the 2 lines.
Okay. So you're typing in the libraries? Are you typing in the libraries or are you copying and
No,
pasting?
no, not the libraries. I'm gonna copy that. I'm just typing what you did first.
Oh, okay. Okay.
Yeah, sorry.
Ah, yes. Thank you. Bryant reminded everyone on Zoom, make sure you print your name in the chat for attendance. Very important. Thank you. Thank you.
Maya joined, right?
Mhm.
Well,
I think everyone typed their name in, I believe, unless someone came in later, perhaps. And I think Maya posted directly to me instead of the group. I don't know. Yeah, perhaps. Yeah. So Maya, do you know how to switch that to do a message to the entire group? Just click on the little
No,
arrow.
but I'll figure. Yeah, I'll
no,
figure
next
out.
to the arrow next to your name, do meeting group chat and then post your name. This way it goes on the master list, you know? So you know in the to area, when you're sending a message to someone in the chat, just click on the little arrow and meeting group chat and then send your message. And this way it goes to the master. No worries. I do that all the time. I accidentally send it to a particular person. And then they say, what do you want? What's going on? All right. How are we doing? Did everyone get the
The links are where? I'm sorry.
okay, there's no link. There's actually a direct text
Codes.
dump. It's on Slack and it's also under the homework and it's also on Zoom. Did you see it? It starts with, import libraries. It's pretty long. If on Zoom, it's at 5:55 p.m. If you see the timestamp, because there's been some posts since then.
I don't, but hold up.
In the chat to be specific.
All right. Did you get it? All right, so we're going to upload our
I'm
data.
sorry, why can't I see it? It's I'm sorry, I'm being in a pain. It's below where? I'm on the data, the open hub. I'm sorry.
It's not on Open Hub. It's on Slack and it's also posted under, okay, it's on Slack under data_analytics-homework. And it's also on the Zoom chat. And it was posted at 5:55 p.m. if that helps you, the timestamp. It might be easier to grab it from Slack. And again, after you copy and paste it, make sure it looks like what you see on the screen here, because you don't want to wrap things around. It's not going to be able to execute it. And when you think it's good, go ahead and execute it. If you get a green check mark, you're good. Okay.
Yeah, couldn't the slot on the shot, but that's fine.
Okay. Do you find it on Slack?
Oh, sorry.
I'm upstairs.
Ad assistenza para sábado.
All right. We're now going to upload our data, and the way we're
Oh,
going to
but
do
I'm on Slack right now. I'm sorry. Where is it on the chat? On the
it's
data analytic homework, right?
data analytics homework. Yes.
Oh, yeah, yes.
Is Miss Yulia here tonight?
Oh, she's upstairs.
She's upstairs, where? This is type 2, right?
No,
Uh,
Can you tell me where she is upstairs?
Oh.
Did you find it and copy it?
Yes,
Okay, and you
yes, I'm
executed
good.
it?
Yeah.
All right.
It's good.
Okay, good, good, good.
Sorry
All
about
right,
that.
that's okay. So the next thing we're going to do is we're going to upload our data. And the way you want to do this, and you want to be careful with this because it needs to go in the right spot, is you want to come down and click on this little folder. It looks like it says files when you mouse over. And that's going to take you exactly where you need to upload your data. What you want to do is you want to right click on sample data and click upload. And you're going to browse to where the iris data set is. And you're going to click open and click OK. Okay, so you can see I have it here. And then you want to right click on sample data again, click upload, and you want to click on the image iris underscore types JPEG. We need both of those. So these are the two data files we are working with here.
So it's not uploading.
So after you uploaded it, then what? Go back to,
You're going to right click on sample data and upload the second file. Right click and upload. So you can see I have the two files here.
iris CSV and then iris types.
Yes. Okay.
I only have the iris CSV. Where did the iris type come from?
You downloaded it from OpenHub.
Oh boy, I only downloaded iris.
Yeah, I had said there's two files we're working with tonight.
Sorry, I didn't. I only downloaded. So the other one is where?
Under
On
class
OpenHub.
Yeah, under class 1, there's iris types image.
Oh, okay, okay. I remember. That's the others. Got it. Hold on.
So
You're trying to find
I think I found it, but I need, so it has the JPEG and then I have the zip file, right?
Oh, yes, that's wrong.
But it isn't?
The zip file, we don't done.
We don't? No, she said we do. There's two.
It's the image file and the CSV file.
It's a zip file though. You have to extract it.
Yeah.
The data is a zip file, yes.
Yeah, you have to extract it. That's fine.
Right.
So downloads. 7 and there you go. Get this out, that's fine. Yes, she only wants the CSV file. And the JPEG. That's it. She can't upload CSV files. I just something to say. And on our website.
Right. Only certain types are accepted for security reasons. So anytime you have that type of scenario, you always zip it. Even if you're emailing a file that it won't accept, you can zip it and usually get it through. So
Like, that one didn't work.
is everyone able to upload the
The
CS?
iris type image is only a picture.
Yeah, it's a picture.
It's not oh, okay, it's not letting me save it so that I could upload it now.
It's not letting you save it. Do you have a message on your screen or?
It's just showing up as a preview, and then I'm trying to put it on downloads.
Do you don't see it in the downloads folder?
No, that's what I'm having problems with.
All right. Why don't you share your screen? Let's see.
Okay, let me see. Share. So it's right here.
Okay, so close out that preview.
Yeah.
Okay,
So when I
and
go to
go to
collab,
your downloads folder. Please go to your downloads folder.
oh, I don't go through here. So to sample data.
This is where you upload. You claim that it was never downloaded, so you can't upload what hasn't been downloaded.
Oh, so let me
That's
just
just a
go to-
logic thing. I want to make sure that it's there. So I do not see iris types unless you have your downloads ordered by file type, which is possible. Do you know how you have your downloads folder
by
ordered?
file types. Yeah. So
Well, it
you
looks
see the
like
iris is not there.
actually it's alphabetical. It's alphabetical. And so it's not by type because you have dot pages in different orders. So it is.
Oh, okay. So
Yep,
but it's not there. You see that?
I do see that. So let's go back to Open Hub.
Okay.
Okay, and see the image, right click on it. Can you right click? Even though
I'm working on a Mac today. I don't know what got to me. I'm sorry.
that's okay, but I believe you can right click on a Mac.
I could just click it. There it is.
Oh, there it is. Okay, and you've actually downloaded it before, but it probably went to pictures. So let's click on the download up top there where the little arrow, yep. And let's go to right click, go to the actual folder. No.
This is the preview.
I know it's a preview. I'm
I know,
trying to guide
trying.
you,
So-
trying to guide you.
I'm sorry.
That's okay. So go to the folder.
Right here.
Show in folder, yes. All right. Now, because it's named with a parentheses 2, we're going to have to rename it.
Okay.
So you want to rename it and make it just iris underscore types. Don't get rid of the period for the JPEG.
I was just gonna ask you that. Okay.
And press
I
enter.
added the period. Okay. Oh, it put it a 1 there.
Well, it put a 1. Okay, so let's go find the other one. Go to your downloads arrow up top again, and let's pick.
Oh, look, it's better.
Okay, that's the one. Okay.
It.
Okay. So now you're going to go to Colab and right click on sample data, upload, and you're going to grab just the iris underscore types.
From the download, right?
Yes, that's where it went. Keep going somewhere. It's. Can you sort it by clicking on?
Let me just.
Underscore. I don't see an underscore there. There you go. Now grab
this one, right?
That one. Yep. Okay.
Perfect. It's there. Oh,
all right. Now you have a problem. Hold it. You have a problem. You have an extra space after the S. So that's not going to work. So delete that one. Click on the 3 dots. And delete file. Yep. Delete file. And we want to go back to your downloads folder and make sure you get the one that doesn't have the space. That's got to Scroll down.
This one?
No, scroll down. Scroll down. That one. So when you grab it, that one does
This
not
one?
have a space. Yes. So right click on sample data. Nope, not that
No,
one.
no, I'm just trying to delete. Right click on here.
No, right click on sample data. Nope,
Oh,
sample.
okay. Mm-hmm.
And go to upload. And make sure you get the one that doesn't have the space after the S. Iris underscore types. No, underscore. That one. Yep. Okay.
Perfect.
All right. And can you expand sample data just to make sure it's there? Okay, perfect.
Yep, it's there. Thank you.
All right, you're welcome. Okay, so. All right, so now that we've done that, we are now going to create a new section. And to get back to sections, I'm going to click on the folders over here. It says files. All right, whoops. I'm sorry, I'm going to click, I'm going to click on this up here, table of contents, my bad, and click on section. And double click on new section, and we're going to put in import data. Why? Because that's what this section is doing. Okay, so again, this is table of contents. We were just here, so you want to click on this table of contents. All right. So we are importing the iris data set, and in a little bit, we will import the other, the image. Right now, we're just going to import the data set. So you want to do very much like last week, create the command to import the data set. Okay. Now, mine's saying there is no such file as iris.csv. How special? Let me see if this did not refresh. And let's try it again. I might actually have to I might have gotten booted out. Hold on. That's interesting. We can see it right there. Oh, I know what the problem is. Okay, I know what the problem is. So hold on. I'm assuming it didn't work for you guys either. Can we just verify?
No.
It didn't work? Okay, all right. And that's because we have to go actually up to content and put it there. So that's my bad. But in a way, it's good because this way you'll know that it doesn't belong in sample data, it belongs in content. So I'm going to show you how to drag it into the content folder. All right. So did everyone see how I went up a level? I clicked on this little, let's see, we were in here, and all I did was click up a level to content. So let me go like this. Let me go back. We were here, right? And I just went up a level. There's an arrow, not the upload arrow, but there's another arrow. It's like a black arrow that goes up. Everyone find it? Did everyone?
Yeah, if I move to find it, I will lose your screen. I don't know how to keep your screen and my screen at the same time.
Well, you don't need to see my screen as long as you can see the content folder, and then you can then look at my screen and watch what I'm about to do. I'm just copying and dragging this into the content folder. So the goal is just to drag and drop them. And I think you've done that before because remember, you were really good at it.
No.
It's right. So it's got to be at the content level, not sample data level. That's my bad. Okay. Was everyone able to do that?
Wait.
Yep. It will run now. It's supposed to be in the content folder. So in my mind, I was in the right place, but it wasn't the right place. But again, it's good because this way you'll understand that If I don't put it in content, I can't import it this way. This command assumes that your data's in the content folder on Google Drive. And every user on Google Drive has a content folder. Well, if you don't put it there, it's not going to be able to find it because it assumes that. Okay. So again, we just went up a level. Notice how sample data is a subfolder from content. We just went up a level into the content folder. Was everyone able to run the command? All right, Renita says yes, Walker says yes. Janine, you're good, I hope. Karen, are you good?
So,
Mm-hmm.
Sorry, to bring the file, the Irish file.
You're just dragging it and dropping it into the content folder.
Okay.
And if that's too difficult, you could actually, upload it the way we did before, but it's more ideal to just drag it and drop it. Just drag and lay it on top of the content folder. All right, Maya's good. Karen, you're good. All right, is anyone not able to run the command now?
I haven't been able to drop it.
You can't drag and drop it? Are you having trouble with the mouse or?
Sorry, trouble finding the content folder.
Okay, so when you were in sample data, right, you had an arrow that pointed upward and you should be able to just click on it to go up a level. Do you see an arrow next to sample?
Yeah, I see it. Okay, so okay.
And then you will see the content folder because it's literally one level up. And the content folder is the third down from the root, basically.
Found the content folder. So I'm taking the iris data.
The iris.csv and the iris_types.jpg file. You're putting it in the content folder.
Oh, I see.
Were you able to get that there?
No, I'm just gonna have to go and upload them because
Okay. Just make sure you get the right one. All right, and for those of you that are waiting, we're going to view the data set because we want to make sure that the data set looks normal and what does it look like and such. So we're going to just run a head command off of the data set with nothing in the parentheses. We want the first 5 records. And when you don't specify anything in the parentheses, that's exactly what you get, the first 5 records. Okay.
So now they're there. So what do I do now? Just
you have to import your data set using this command.
Hold on, let me go back to this. I wrote the same thing you have there on the code. Oh wait, I had to put head.
Did you import your data set yet?
Yes, I did. It's there.
Okay.
In the folder, in content folder.
No. You're saying it's in the content folder. That means it's located on Google Drive. Ingesting the data set into your notebook is a different process.
No, I haven't done that. But I still have to type data set head.
Well, it's pointless to do that and run it if you haven't brought your data in.
No, I have the data on the collab, on the contact.
You're not hearing me, I don't think. Just because you have your data here doesn't mean you can view the first 5 rows. You have to import the data set. Do you see the code that is highlighted?
Yes, I typed that.
Did you execute it?
I did. No, not yet. Let me see. Hold on.
It has to be executed or else the notebook will not know that the data is available for use. It won't be stored in memory.
Got it. Hold on. Whoosh. Oh, shit. All right. I'm not seeing the arrow. Why is that? I wrote one. I don't know. Could I share my screen?
Okay, are you using a code cell
Yes.
and you're not seeing an arrow?
Maybe I'm not using a code cell. Hold on.
Yeah, delete what you have and you should see
Oh,
that
that's
black.
what it was. That I wasn't using.
Yeah, you can't, because you can't execute text, right? It's kind of just like a label. In order to execute it, you have to have the code cell.
Yeah, let me just get rid of this. Okay. So yeah, I have the code cell now. I executed it and it's good. Now I'm ready to import the data. Right?
I thought you already imported it. You said you just
No,
executed.
I mean in the code, like into it. I already have it on the content folder.
But the content folder is what we did earlier. What is highlighted here, this command that you typed doesn't have anything to do with the content folder. This command is ingesting the data into the notebook from the content folder.
Okay, so I already did that.
Okay, so now you're going to show the first 5 rows, and that will confirm that everything's working correctly.
There's a extra number 2. Oh gosh.
And extra number 2?
Yeah, let me just hold on. Somebody's sharing. You are sharing. I just need to.
Well, I'm teaching, yes, so I'm
No,
sharing.
I wanted to show you the extra. I got rid of it. So I already ran it. That's why it says show a section there.
No, it shows section because you put in a section.
No, once I run it, it's just those in number 2 extra on the bottom.
2 extra what?
No, and number 2.
Number 2.
So I wrote, no, you see how you have 1?
This is a comment on line 1.
Right.
On line 2 is the command to load the data set first 5 rows.
Yeah, I don't have that. I had to type
That's
that.
because you don't have line numbers. And given time tonight, I'm not going to show you how to turn on line numbers. We don't have time for that.
Don't worry about it. Continue.
Okay, yeah. We can show, maybe during office hours, they can show you how to turn on line numbers. I did that last week. What we need to do is, because we're not gonna get this done. So we're gonna go to the next command. So we want to know how much data is in our data set. Now we already know it, but it's good to have a confirmation that all the records came in. All right. So we're going to use a command that you've used before. And that is dataset.shape. That gives you the amount of rows and columns.
Would you mind showing the real quick?
Showing what?
the top real quick. I'm just gonna take a screenshot real quick so I could type it. Of the code that you should type on the above.
Which code? There's only this code right here. This is the only code.
There. I just didn't. Go ahead, continue. I
You know,
won't bother you.
you can get this also from the recording, but yeah, you're trying to type it in class, I guess. Yeah.
Yes, I am. I'm sorry.
Okay, that's all right. So your data came in okay. And do you know how big your data set is? Yes?
Yes, I'm good. I'm good. Go ahead, continue.
Okay. So looking at our data set, who can tell me what the target variable is? Does anybody know?
Easy?
0, 1, and 4.
Species. No. Species is the target variable. Remember, we're predicting, if you look at here, the type of iris. And this is the species, the type of iris. Yeah. All right. So that is what we are predicting, right? Now we're only seeing the first 5 records, but we believe that there is all 3 species represented. I can tell you they are. So what we're going to do now is bring down another code cell, and that code cell we're going to use to give us an image. Now we imported a library that allows us to see an image in line. And this is using matplotlib. Okay, I'm going to scroll up a little. And it takes a little bit to bring the image in, but that is what it looks like. And let me get that like that so you can see. Scroll up a little there. Now it's a little big, so I'm going to make it a little smaller, just so that you can see the screen. So I'm going to take this down by half on both of these and rerun it. Voila. Oop. So what's nice is you're able to show images using the library that we imported that basically supports viewing images inline. That's why we say matplotlib inline. We want to see it in the notebook itself. And what's nice is matplotlib has the .image library, which allows us to manipulate, the quality of our notebook. So it's nice if you have a chart or something that's external and you want to see it. In this case, we're bringing this in so we know what the different species look like. So once everyone has the image loaded in, let me know, and I want to talk about what we see here. So just like we read in our CSV, we're able to read in an image, and that's the command for that, mp image, img.imread. And then, of course, you specify the name of your file, which we put in our content folder. And because the name matches what the file name is, we're good. Now we don't need an access because it's not a chart, it's actually an image. So we don't need anything else other than the image itself. And that's why we have the access turned off.
I think I have a syntax error, but it also keeps like popping up things in my code, which is very strange. Usually
Okay.
it just gives the error at the bottom,
Okay.
but it's
So
like
check your code to make
popping
sure.
in. So I'm
So
trying to fix it, but
syntax,
it keeps
okay,
throwing up
syntax,
things in. I don't know why.
okay,
I keep deleting things, but it keeps throwing in.
well, let me
Must be a
ask you a
delay.
question. Would you like me to assist you? Because if you have a syntax error,
Yes.
okay, then you want to compare the code that you used against the code that you see on the screen. So for example, on line 1, the percent sign cannot have any spaces after it. That would be the first thing I would look at. Make sure you have M's, instead of N's. Sometimes that looks the same. Just verify that your code is identical to what you see on the screen here. Because syntax means that you typed in something that the library doesn't understand and it can't compile it. So just double check.
It seems to be behaving a little bit more now in terms of letting me type in without doing a bunch of other random things.
So
like
it's not
adding
even letting
stuff.
you type?
No, it is now, but it was like, okay, think it's running now. Yes, okay.
All right, so you see the
It was
pictures?
very strange. It was actually adding things into the code.
Lovely.
Yeah, I'm good now.
Beautiful. Do you have a dog? Maybe the dog is typing. You never know. My dog wants to type, but I won't let her. Only God knows what would happen. Rocket ships would be, going off and stuff. So she knows I'm talking about her. She's giving me a dirty look. And again, I changed the file size just to make it smaller so that we can kind of see it on screen and what have you. Was everyone able to load their image?
Yeah.
All right. So when you first look at this, I'm going to ask you a question. How many classes do we have?
3.
Excellent. Multi-class, right? 3. Would you say that 2 of the classes look similar and 1 looks different?
Yeah.
Yeah.
All right. Which ones look similar?
Vesicolor and vice
Virginica, right? The ones with the V's, right?
Yes.
Yes, they're very similar in their characteristics. Visually, we see. So remember, we're looking at it and say, well, the petals look kind of the same. The middle looks kind of the same. They look like the same size. And then the setosa looks a little different. It's in the same family, but it looks a little different. Now, this is a direct observation. We're not looking at the data and making those determinations. But this is, when you look at images that represent your class, you want to make sure that they're representative so you have an understanding as to what do these irises even look like, right? Why work with data when you don't know what it is? So that's why we did this, but also to show you how to bring an image into your notebook. It's very beneficial, very, very beneficial to do this. So the next thing we're going to do is describe our data set. And this is very easy. We've done this before. It's just dataset.describe. Again, the name of our data frame that holds our data is dataset. And we're just asking it to describe our data set. Now, when we do this, it's only looking at numeric columns or features. So it's not using the species column because that is not numeric. All right. And what this is giving us is the count, the average sepal length, sepal width, petal length, petal width, and so on and so forth. It's basically giving us the, average, the summary statistics for our numeric values, which are the characteristics for our flowers. So it just gives us an idea of the range, okay? So for example, when we're looking at petal width and sepal width, we're looking at a ratio of petal, right? Sepal and petal. We can see that the petals are smaller than the sepal, right? And so on. It just gives us a general idea of what's happening with our data. It's always good to run this to see. It also gives us our Q1, remember our Q1, where the majority of the data is, which is 50%, and then where our data at the Q3, we're looking for any tails. Is there any outliers or anything like that? Okay. Based on our data set, there is not any outliers here. The numbers are in close proximity. From the minimum to the max, there's nothing really, off the charts here. There is some variability, and we will see that when we actually complete this whole exercise. All right. So the next thing we're going to do is we are going to get basic info. Now, why do we do this? Why do we get basic info for our data? Well, this tells us what our data types are, right? Now, why is this important when it comes to machine learning? Did anyone remember? Anyone?
We need to normalize the data.
Well, we have to normalize it, but what do we know about machine learning models? Can it handle the species data?
No.
That's
It
correct.
has to be numeric, no?
It has to be numeric. Excellent, excellent. So we know, just looking at this, we have four columns that are float 64, which are numerics, and then we have our target variable, which is an object. Okay, and so basically we have a data set that is going to work well with our model, and so we're good to go at this point. But if you saw some of the characteristic, and hint, I'm alluding to the homework, if you have features that are a data type that can't be used by the model, you have to either delete those features and not use them for your model, or you have to convert them. Okay. And I haven't showed you how to convert them yet, or I have, but it's been a while. So just think about that for homework, how you're going to handle that. So we do want to know how many classes are present, even though we know visually we have only 3, right? It would be nice to know how many unique classes there are. And this is another way of determining what the classes are. If, let's say, we didn't have a picture and we had our data set, which we ran the head command and we only had the first 5 rows and it only showed Setosa, we don't know how many there are. Well, technically we do because the problem statement told us, but it's always good to make sure that the data truly has just 3, right? And that's why we're doing that. Okay. Now, the next command we're going to run, once you get this typed, is going to take a while to run. For some of you, if you have a poor internet connection, but we don't have a lot of data, so you should be okay. This is going to allow us to check the distribution of data, and we're going to use a pair plot. So I'm going to run it and show you what it looks like. You're going to type the code and then run it, but don't click it twice. Just let it percolate because it does take a minute to run. All right. And there's a reason why it takes a little bit of time to run. It's because it's doing combining. All right. It's doing combining.
It's beautiful though.
It is, and it's very meaningful. There are inferences that you can gain from this. Once everyone gets the code typed and they run it, we're going to talk about what do the colors mean, because this is really important. There's a reason why we use the hue of species. By saying hue, it means give us a legend that's colored differently for each type of species. So Setosa is blue, Versicolor is orange, and then Virginica is green. And so it allows us to see the data differently. And when everyone's done, I'm going to show you how to make inferences from this. This is going to blow your mind. Once you get this typed and you run it, and I explain to you what you're seeing here, this is going to blow your mind, because I want you to remember the picture and which one was different. And then look at your color and tell me if it matches the picture that we brought in. It's like back in the day when you were kids and you say, which picture is different? All right, same thing. Which one does not look like the other one? When you get it run, let me know so we know that everyone's good. And again, it takes a second to run it, so don't get impatient and click twice, because then you're executing the command twice, and then the server's going to say, really? I only had so much coffee. Wait for me. All right, good. Excellent, Maya, thank you. Renita's good, yes. So pair plots are awesome because you can see you get a pair, you get a combination of all the different possibilities. And when you think about it, we're comparing each class on the characteristics of each of those classes. All right, Janine is good, yay. All right, anybody not get that command run? Which one is different? Setosa. And notice how in physical approximation, see how it's the blue is clustered away from the green and the orange? The green and the orange are clustered together. We're going to be doing a clustering algorithm in a future class, but they're tightly clustered together with a few out points, little dots outside, but they are meshed together, whereas the blue is separate. Well, guess what? That actually matches our observation up here. We saw that one of them was different. We see that physically it's different. It seems like the width of the petals and such are not the same, right? Well, guess what? The data is representative of what we're directly observing. How cool is that? When you look at the histogram, you can see the blue on like sepal length is really tall, right? And so you can see that setosa is very different when it comes to sepal length. And then if you scroll down, you can see that sepal width is actually greater for the orange and the green, right? Which matches what we saw visually. And then when we come down to petal length, setosa is hugely different, right? And I'm right down here, this third square over, right? You can see the two little mountains here, the third cell from the left. The green and the orange are very similar in petal length when it looks at the species, but the setosa is very different. So not a normal distribution for the setosa. It's real tall and skinny, right? These guys are more of a normal distribution and they share those qualities. Does this make sense to everyone?
Yes.
Yeah, and you're using the data, not the image for this,
Amen.
obviously, right?
Amen. That's correct. And there's a big difference.
Hallelujah.
Hallelujah, right? So think about it. If we use just the image, Photoshop, people can make it look like anything, right? So, an image can be tweaked and made to look different and what have you. Just so happens that particular image is a research image. So they went out in the field as a lab and, took pictures of the flowers. So they're not going to make them different just for fun, right? So the image is actually a quality image, but this then matches the image. And from a scientific point of view, if they were trying to create a catalog of species of flowers, they want to represent them accurately. So it would be, very unusual if they took an image and photoshopped it, right? But what's nice is this is coming from the data. So we already know at this point, one of them is different. Now, the model is hopefully going to see that as well. We're going to be able to determine how the model sees it, because how we see it doesn't matter. We want the model to do the predicting, right? But this visual is very, very interesting. And that's why we did that. Okay. All right. Let's go to the next thing. we are going to do a correlation heat map because we love them. It's another visual way of looking at our data. All right. And we're going to talk about this, and then we're going to take a quick break. So I'm going to just scroll up a little so you can see. And you're going to get a future warning on that. Don't worry about it. It's fine. It's not a bad thing. And once you get that typed, let me know. And then I'm going to ask you a question about which ones are correlated. Now, it's always good to see if attributes are correlated because the model is going to see them as correlated. So you want to know what you're working with, okay? That's why we're doing this, to see what correlations are present.
So if I go by this data, could I assume that the first V and the S are correlated?
Okay, when you say V and S, what do you
Oh,
mean?
I'm talking about the flowers, the petals.
No.
Like
These are the attributes of the flower. So if you look on the left when you run it, for example, the first row, that's sepal length, and you come over to the first 87 that you see, you then scroll down and you'll see what it correlates with. So sepal length and petal length correlate at 87%, which is a high correlation. Does that make sense? So this is the attributes of the flowers, not the flowers themselves. This is like the qualities of them, the characteristics. So every flower has a sepal length. It's looking at the correlation between the attribute. Make sense?
yes, it
Yeah.
does. Great.
Yep.
Thank you.
And I always start from the left. So you start at the left and say, okay, sepal length, which is a high correlation. Well, if we look down here, petal length intersects this orange square is petal length, right? So one axis has one and one axis has the other, and you see where they intersect, and that's the correlation. So here we have a 0.82. So sepal length also correlates with petal
I
width,
got one.
right? What's another correlation that you see?
Petal length and petal width.
You got it. Petal length, right? So petal length and petal width, very highly correlated. My goodness, 0.96, almost perfect, right? And what else?
Wouldn't you say that it also show you the non-correlation, like 1 and 0, and minus 0, 11?
No. This is a correlation, but when you see negative, that is a negative correlation. But when you see 0.11, it's not meaningful. So
Okay.
anything over 70 and above is considered meaningful. Yeah. So we ignore the little guys, the 42, the 36, we ignore that. The perfect ones, of course, any attribute is going to correlate perfectly with itself. So the ones we ignore because, of course, it's going to correlate with itself. We're looking at anything that's 0.87 and above. And at this point, we don't have any 0.7, so that's why we're going to 80 and above. And that's what we're looking at. So here, for example, petal width and sepal length is 0.82. There's a high correlation, very strong correlation. And petal length and petal width is very, so 0.96 is almost perfect correlation. All right. Now this has to do with the
Can you
physical.
describe what that is? What in terms of a flower? Like I don't quite understand.
Okay, so a petal, right, is, and I'm going to just show you with the picture. A petal is this guy here, right? That's your petal, the end part. The sepal is which part? What do you think?
Is it
Like
the middle, the center?
The center
leading to the petal?
leading to the petal. There you go. Now, but you raise a good point, Walker, and I'm glad you asked. So if you're working with attributes that you don't know what they are, and it's okay if you don't, you always want to Google it, right? And see, because, you know, I'm not a flower expert. Maybe you're not into flowers. Those that like at the lab, they groove on that stuff, right? That's their thing, right? But if you're not sure what it is, it's always a good idea, right? So irises have certain, you know, things about them. They've got these little things going away from here. So you see how they've got almost like a second leaf almost. So you want to make sure you know which one is the sepal, which one of course is the petal. All right. Um, and they're all very pretty. So that's important. Okay. So going back to our correlation, it would make sense that the petal length and width would correlate, right? Because, you know, it can't be too long or too wide. If it's not long enough and it's too wide, it may droop. You know, it's the way the man upstairs said, I'm going to design an iris. And, you know, so, but it's super important. So really the length of the sepal and the petal is important. The petal width and the sepal is important. And again, it's a structural thing. So if you're thinking about, you know, what makes a flower stand up nice and tall and, you know, buoyant and it doesn't droop, it has to be designed a certain way so that it physically can stand. Plus, it has to have enough water, which, by the way, is turgor pressure. I am a plant, well, turgor pressure is how much pressure in the veins due to water and moisture, right? So there's a lot of factors that go into plants. So this goes back to something that we talked about in Intro to Data Analytics is domain knowledge. So if you were having to analyze a data set that you're not really, you know, familiar with the terms, you would have to research it and become savvy in the domain knowledge for that, you know, domain of interest. And so, you know, it's super important to ask questions like Walker did. You know, what does this mean? So, all right.
So are these
Okay. hmm Go ahead.
these are just, is this the correlation of all three species? Or
Yes, combined. So, and that's another great question. So what we said is every species, each of the three has a sepal width and has a petal width and so on. So what we're doing is looking at all of the data for all the species, all the classes together. That's a great question. So
Okay.
remember, when we put the data into the model, we're giving it data from all three. And this is showing us how correlated the attributes for that data is. And it involves all three flower types. Does that make sense?
Okay.
Yep. So we're not, you know, we're not specifying between the classes at this point. We're looking at the characteristics. We're actually looking at, and I'll show you really quick here. We are looking at this data right here, except for the species. So we're looking at this numeric data, right, that all of the iris species have, regardless of what. So we're ignoring the target at this point. We're just looking at the data that will be ingested as predictor variables, right? So we're looking at how correlated is the predictor data, right? Because the model is going to pick up on those patterns too, but we need to know before we actually build the model. And that's why we're doing that. Does that help, Walker?
I think so. I think I'm gonna just Google like data correlation right now during the break, so I can I think maybe I forgot what that is a little bit, but
Right. So
I'll
so what we're doing, we're actually seeing how correlated the attributes are. So for example,
right.
instead of flowers, you know, is there a high correlation between a person's blue eyes and their chromosomes? Well, of course, but it's a particular part of the chromosome, right? So if you look at your helix, and your DNA, without getting crazy, there's a portion of your DNA that predicts eye color, right? And so that's basically what we're looking at. We're looking at the characteristics of the flower, and seeing how correlated the characteristics are with each other. Yep. So
it would be like saying, like, the length of a cat's nails versus the
size of its paws.
size of its size of its paws, or like if it has long nails and pointy ears, it's a cat. Well, we're not doing that yet.
We're not
right?
doing that, but that's actually a great point. So here's the thing. Because other things have pointy ears, elves have pointy ears. We couldn't say that, right? We would have to have enough data about a particular species of cat, because some of those have pointier ears than others. Like a lynx has a pointier ear than a domestic feline, right? So, but that would be part of the puzzle, though, right? So pointed ears, well, dogs have pointed ears too. So, right. But I think you get it. I think you get it. It's two characteristics of the thing that we're looking to predict.
Okay.
So in the case of dog versus cat, there's other things that make the dog a dog and separates it from a cat.
Right.
The type of claws, for example.
Right.
Now, I'm not a claw expert, but visually, when you look at the claws, there's a difference. I don't know what it's called in, like, yeah, but I'm sure there's a name for it, right? So yeah, and you'd be looking at comparing felines versus canines. That would be your species. Yeah. Excellent. Excellent. See, it's starting to make sense. All right, we're going to take a quick break. I'm going to pause our recording. We want to get just refreshment. Oh, all right, we are recording once again. How is everybody doing? Good, I hope. We are going to bring down a new section. Okay. So remember, under table of contents is where a new section is. And even though the data seems like it's great, we need to pre-process it. So because our model has certain requirements. So we're going to create a section called data pre-processing. All right, and just so that we know that this is a logical break between what we were doing, which was basically exploratory data analysis, and now we're going to do data pre-processing to get it ready for the model. Okay. Now, to do that, the first step, if you remember, is to create the two sets of variables. We have explanatory or predictive and target variables. We need to assign it to uppercase X and lowercase y. So our data set has a certain amount of columns. We're asking it to bring in all the rows and only the first 4 columns. And we're excluding the target, right? You never bring that into the predictor. That is always going to be y. Now, if you want, you can copy and paste your code from last week for these two things that we're doing, because it's very similar. You will have to tweak it just to make sure you have the right columns, right? This one is actually identical to last week, so you could always copy and paste this from your code from last week. Here, we're splitting the data set into our training set and our test set. Again, we're getting the model, we're getting the data ready for the model. And if you want to cheat, you can just grab it from last week and copy and paste it in. Just verify you have 25% for your test size. We're using that in a random state of 0. And when everyone gets that in there, just let me know. And then I'll go forward because I don't want to go too far, too quick. So you'll notice that what we did above is X and Y, and our command right here refers to X and Y. And so it knows which is which is the target and which is the predictor variables. And this command understands that because it's designed to work with that kind of information. Everybody have that?
Yes.
All right. So what do we do after we split our data set into training and testing? Anybody?
Normalize.
Normalize. Excellent. So we're going to scale our data. Excellent. Whoops, that's the wrong command. Let me get the right one. So we normalize it because we want to make sure that, and sorry about that, I have an extra cell. We want to make sure that our data is all perceived the same. And now we're talking about the numeric data, right? So what we're going to do is feature scaling to normalize using what we call standard scalar. Now there's different types of scalars out there. We're going to standardize using standard scalar. It seems fitting, right? You can have min-max scalar. There's different types of scalars that are offered out there. But for now, we're going to do the standard scalar.
Oh.
Now we're scaling the X part, right? You see, we're not touching the Y part because the Y part involves the target. Oh, excellent, Janine. Thank you. Since the Y involves the target, we're not scaling that. Now notice it says that we're fitting it and we're transforming it. That's all part of the standard scalar. So once you instantiate your standard scalar, then you fit the data and transform it so that it is scaled in a normalized fashion. So no one particular value looks differently than the other or significantly different. It's not, off the charts different. All right, did everyone get that? Getting there? Okay. Excellent. So now the next thing we do is we create the multi-class logistical regression model. So this right here, I'm going to ask you to type this one. There's some others that I will give to you that are longer, but I want you to type this one. And the reason for that is we have multi-class equals auto. Remember, I referred to that. Okay. So you want to make sure this is the same as what we did last week, but we're naming it classifier instead of what we named it last week. But we're also using the multi-class. We're telling this particular logistic regression model that, by the way, we're going to be sending you multi-class data, not binary, but multi. And we're using a random state of 0, so everyone has the same results in their model. Everybody's model is performing the same. And then, of course, we're going to fit the training data to the model, both the predictor variables and the target variable. So we're actually building the model that we're going to be using to make those predictions that we want. And we're giving it the data. As a matter of fact, line 3, we're passing in the data so it can fit it to the model. And that's that ingesting part. Now, at this point, it has not made any predictions. We've just fed in the data and it's actually learned Okay, it's learned the data. It's become friends with it. It's like a little gnome sitting behind the screen doing its thing. And it's saying, aha, I see data. It's actually, looked at the data internally. So it's actually at this point taken the data in, it's learned, and we're hoping that it's performing well. We don't know yet. That's okay. So the next step, does everyone have this done, by the way, this particular command?
Yes.
And okay, and you have your logistic regression model done. Now we're going to feed it the test data and let it use that data to make predictions. So this is a set of predictions that it made.
Are these like combinations of?
It's not a combination. That's a great question. Great question. So this is not the pairing yet. I'm going to show you the pairing in a minute. So it has paired it internally. What it's done is it's done all the combinations. Remember I talked about how you're combining all the classes? It's done a whole bunch of combinations and combining. All right. But it hasn't told you what it actually came up with. All right. So this looks like mumbo jumbo, just kind of plop, right? It doesn't look like much.
Possibilities, right?
Right. All the possibilities, all the combinations, right. But it hasn't paired them up to say, okay, based on what I've learned, this is what I matched with what. And we're going to look at that next.
Could you scroll up a tiny bit?
Sure. This way?
Yeah, thank you.
Okay. Yep.
Can I? Only have the one.
So this, just so everyone understands, this is the predicted values, right? So this is what it came up with predicted wise. This is not the actual data, right? This is the predictions.
Mine just, for some reason, it just gave me Setosa, just repeatedly.
Okay, so then something happened with the standard scaler or something. You want to check your code to make sure. If you have just Setosa, something's not right. So just check your code against the feature scaling part, the creation of the regression model, and you may have to rerun those if you found an error.
All right, got it. Thank you.
Yep. But it's good you recognize that something's not right, right? Because we know we have 3 flavors.
Right.
Right, exactly. So.
Question.
Mm-hmm.
Why would we do the predictable part of the coding or the process versus the actual? Is this a choice of you, the way you place the coding, or is this the way that you usually will?
This is how it's done.
Oh,
So
okay.
you look at what did it predict, and then you say, you have to it actually asks to do the prediction before you compare it. So prediction has to happen first, then you compare it to actual. So this is telling us that it was able to come up with predictions. If you didn't run this, there's a risk that that process didn't work properly. So then you'd attempt to compare it, the prediction to the actual, and it would fail because it never made the predictions. So yeah, so this is why the prediction is always done first before the comparison.
Thank you.
Yep, that's a great question though. So now we are going to compare actual and predicted. So we're going to bring down a new code cell, and this code is very simple. So I'm going to ask you to type this code, and then we're going to get to some more difficult code in a bit. Hopefully we can get this done. Oy vey. Well, we're going to try. We're going to try. So this is creating a variable called y_compare, and it's using NumPy to do a vertical stacking, because the data that we saw above, it's all over the place. We're taking a V stack, we're slicing it vertically and stacking it. And we're going to compare the left side to the right side. Left side is actual, right side is predicted. And we're printing the first top 5 values just to see how well the model did. So now that it's done this way, it makes more sense. So we really built an array. The left side is the actual, the right side is the predicted. And we're just looking at the first 5 values in the data set, of the predicted data set, ypred and ytest, the first 5. Now, since we set random to 0, everyone should get the same result as what I have on the screen here. And that's one of the reasons we set random to 0. Was everyone able to get that?
Yes.
All right. And everyone has the same results. Virginica was the actual, Virginica was predicted. Versicolor, versicolor, Setosa, Setosa, Virginica, you see? So far it looks pretty good, right? So far it looks pretty good. Now, we would like to see a table of all the predictions and see how well it did. So we're going to set that up. This is very simply creating a probability and setting a particular or accepting, I should say, rather than setting the p less than 0.05. So we're looking at anything like 95 and above is going to be a good value. So when we get the table and we see our values, we're going to see how accurate this prediction was. Okay. And for now, you don't have to type the comments. If you want to do that after, just to save time, you can just type the commands. The other thing we're going to want to do is round our number that we get to 2 places, 2 decimal places. We don't want to deal with anything longer than that. So the way you do that is this simple line of code. We basically say, let's turn probs or probabilities underscore y to something that we can work with, which is rounding it to 2 decimal places. That's what that is. Now, the next chunk of code I'm going to give you in Slack and also on chat, because there's no way you're going to want to type this at this hour, and I would not torture you like that. So I'm going to share it on Zoom first. You're going to put this in a new code cell. Okay. And then I'm going to share it on Slack under data analytics homework. And it's a monster, but that's why I'm giving it to you. You're going to want to make sure it looks like my code. Good Lord. And it's long. So just copy and paste it. And it should work fine for you. This is fascinating. And the reason I'm showing you how to do this is you don't need fancy graphics to make a table that is meaningful. This is using pipes to separate the columns. So this is some people call it the caveman approach, but this is pure and it allows us to see the data very easily without glossy colors and things of that nature. So once everyone gets that copied in, just let me know. I don't want to go forward.
Good evening, everyone. The library will be closing in 30 minutes. Please come to the circulation desk at the time, go to the library card, or check out any material. Please note that there will be no benefit. After 7:30, computers will shut down automatically 50 minutes before closing, and once that, it will also be locked. Thank you.
The computers are going to shut down. Did I hear that right?
Those are like the regular computers.
Yeah, I think so.
Yeah, they're not these.
Okay, so are we good if we go to like 10 more minutes?
Yes.
Usually we are. Okay, I want to make sure. That would not be fun. All right, so was everyone able to copy and paste that code into a new cell, that long monster?
Yeah.
Yes.
Okay, so let's talk about what this means. We have our test data, right? Which is the actual. We have the predicted side by side. But look, this is the percentage. I'm going to focus on the first row. Virginica, 99% prediction rate. So the model is 99% sure that it is Virginica, right? It was able to predict Virginica as a species 99% of the time. All right, in this particular combination. Then we have versicolor to versicolor. Well, 93%. So this is a series of predictions that it made, and there's a lot of them here, right? Series of predictions that it made, and we're focusing on the high, not all of it, but some of it, right? Here we have Setosa, right? Now, perfect. Notice a perfect correlation. It predicted it, basically perfectly. All right, but Setosa is very different. And there's also less data for Setosa. So the model got it right because Setosa is special, as we said earlier, right? Here's another one, Virginica to Virginica, and 97%. Notice that this is what it predicted, and sure enough, Setosa to Setosa, 98%. Virginica to Virginica, perfect correlation. Perfect prediction. I should say probability, not correlation. All right. So everyone sees, isn't this cool? You can kind of see the matching that it did. Remember, it's doing binary matching, all the possibilities. So it did this over and over and over again. And then it came up with a numerical probability that it got it right. The model said 99% of the time, I'm going to get this particular one. I'm 99% sure that this particular one that I have highlighted here is a Setosa. All right. It was correct. So how cool is that? That's the beauty of putting this data side by side so we can see. And so this is just a technique. Now, let's make a confusion matrix. So what part was confusing for the model? Let's do that. Very simple code. Let's make a confusion matrix. And this time we're not going to make it fancy, fancy with colors yet. We're just going to make the confusion matrix and visually see where it possibly got hung up. Now, once everyone has this typed, I'm going to explain what this means. This is actually good news from a data point of view. You might be wondering, well, how the heck do I interpret this? The 13, the 15, and the 9 is what it got right. There's only one that it got wrong. That's a pretty good, that's a 99% accuracy score. So when you add up the 13, the 15, and the 9, that tells you how many it got right. And mind you, this is combinations. All right. So that's the other thing. Don't get confused. This is, you might be saying, but we have, 150 records. Well, this is combinations.
Could this be the same kind of coding that they use for like predicting the numbers of the lotto, or not predicting,
Absolutely.
but just programming?
Yes,
Yeah,
this is
that's
a
right, I can see.
statistical function, right? And so statistical functions involve correlations and prediction and probability. And this is involved, it's in that same realm as probability. Yeah.
Mm,
So what is the probability? Like if I'm flipping heads or tails, right, with a coin?
right.
Well, I have two possibilities, a binary, right? Head
Mm.
or tail. I can predict the probability. How do I do that? I flip the coin over and over and over again to see out of all the flipping, how many times was a head, how many times tails. And then I can predict the next flip and what it's going to be. So that's exactly same thing, same type of math.
Wow.
So Walker had posted a video on correlation, and it is in the realms of statistics. Data science uses statistics in a specific way, and other fields use statistics in other ways. But this is you're exactly right, Mackie. That's exactly how it is used. And this is why, if you don't like math, learning some math is good. And if not, you study up on math, you brush up on your stat skills. So that's something that's always a good thing. So we had 38 possibilities. One was bad, one was not good, it didn't match it up, and 37 good. So that's a good ratio. All right. So now what I'm going to do is I am going to give you some more code because it is late. I'm going to post it on Slack. This you're going to put in the next cell. I'm also going to post it in the chat on Zoom. And I'm also going to post it on my screen. This is going to give us our accuracy of our model. Now, I already told you the accuracy, but now I said 99%. It's technically not. The classifier is going to perform, the model is going to perform at a certain percentage, right? So the prediction that we just did, the 99%, is different than this. This is the actual model. So 37 was right, 1 was falsely predicted. But it still did a very good job. 97% is good, but it's also suspect because it's highly unusual. That's because the data is perfect. It's a small data set. It's a research data set. It's been cleaned. It's been normed. It's like the perfect data set, which you never get in the real world. Just saying. Now we also, I'm going to give you the code really quick because we got to hurry. Then in the next cell, you're going to do a visual of the confusion matrix, and I'm going to give it to you on Slack as well, because some folks might like colors and all that fun stuff. All right. And I'm going to give you the rest of the code for time's sake. So each thing I'm giving you, paste in a separate cell. How's that? We'll do it that way. So I'm putting it on, there's another chunk that I'm giving you. You just want to just copy and paste it in and run it, of course. The function, when you create the function, nothing's going to output. That's okay. We're then going to use the function in the next cell. Okay. So again, that's a separate code, and I just pasted it twice because I thought I had Slack and I didn't. Here we go. Just put it in once. You don't need it twice. This is awesome. This part is going to give you a lot of information. And that's the last thing you have to copy and paste. Was everyone able to grab that code? Hopefully.
Yes.
Awesome. So what we learned is that the model has a 97.368 prediction or accuracy. It predicted, here we have Setosa, 13 times Setosa was predicted properly, right? So this is kind of like a correlation between Setosa and Setosa. It's predicted versus actual, right? Versicolor, you can see what it did here. This is kind of a visual of what we just looked at, right? But here in our classification report, we see some additional metrics. We have a perfect prediction for Setosa, a perfect prediction for Versicolor, and a 90% precision rate for Virginica. Now remember, Virginica and Versicolor are very similar, right? Setosa is very different, so that differentiates it. It's different data. So that's one factor. But you can see here that our scores are very high in all ways. The model did really, really well. We have very high, over 80% from top down. When you look at support, does anyone remember what support means? Support is the number of observations for that particular item. So we had 13 Setosa in our data set. It predicted 13. So it used 13 combinations and it came up with, okay, I did really well because I figured it out. 16 for Versicolor, right? Now, one of those was incorrect, right? So Versicolor, there were 16 that were Versicolor. Okay, and in that group, I should say, and basically it did 15 correctly, 1 not correctly. It mistook it as Virginica. And then of course, Virginica, there was 9, and of course it got all 9 correct. And this of course is our matrix. And you can see this is just a, confusion matrix in a beautiful heat map. All right. So I'm going to segue from here and go over your homework really quick. Let me stop sharing this and go open your homework and share that. Okay, so homework. Oop, there it is. All right, now for your homework, did I share you see the homework on the screen?
Yes.
Yes, okay. You're going to use Colab and the Diamonds data set, and you're going to perform multi-class classification. All right, note that this data set is much larger than the one we used in class. So you want to add this parameter, max iter underscore iter equals 60,000. You want to put it right in front of the multi-class portion of your code. So we need to tell the model that you've got a lot of data and you need to iterate a lot of times. The iris data set was small, so we didn't have to put that in there. But if you don't do this, it'll fail. Okay, so if you come to office hours, someone can help you with this. You're basically going to put it, see how logistic regression has a parentheses and random state equals 0, comma. You're going to do max iter, max underscore iter equals 60,000, comma, then solver equals blah, 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 comma, multi-class equals auto. So as long as you put it somewhere in the parentheses separated by comma, you'll be good. All right. You want to use comments in your code to document what the code is doing. And in the conclusion section, write your model performance accuracy and discuss insights as to why you think it performed that way. Okay. Write down any questions you have about the concepts covered in class and bring these to office hours and or post them on Slack. Okay. Under help me out. Make sense? Now I will hint to you that you want to remember the conversation about what can I bring into my model? Only numerics, right? So focus on only numerics when you bring it in, because I haven't shown you how to do one-hot encoding yet or changing the data type and all that fun stuff. Okay. Any questions on this? The data set is on OpenHub. It's called Diamond. And basically, the diamond has a cut. The cut is the target. I'll give you a hint. It's the cut. It's categorical. It's the cut. All right? Bless you.
Exposing it physically good. The bathrooms are now on.
Oh, right.
Okay.
Any
All right,
questions?
we'll all be diamond next.
Diamond experts. Yes, you'll learn stuff. So any questions? I know it's a lot. Don't feel, don't think that, I think you're getting better at figuring this stuff out though. Does it seem like it makes more sense? I hope.
Yeah.
Okay. So prediction is
We'll
good.
see.
We just went from, let's see, we went from flowers. Well, no, last week we did what? We predicted what?
Breast cancer?
Yes. Then we went to flowers and now we're going to diamonds. I mean, who knew? Next, we're going to predict the lottery all win, and then we have to worry about it. Right? Yeah.
Quick question. I'm
yes,
sorry.
that's okay.
You said that we could find the diamond data set where at the
On
OpenHub?
OpenHub under this class. Yeah, where you downloaded the other data sets.
Perfect. Thank
You
you.
got it. Yep. And the homework sheet is in there too to explain what to do. All right. And again, office hours, highly encourage it. This one's a challenge. I think you can do it. All right. I'm going to stop recording. Thank you so much, everyone. I look forward to seeing you in office hours and on Slack, okay?
Okay, thank you.
You're welcome. You're welcome. Have a good night, everyone.
Good night.
Good
Good night, Dr.
night.